Yeah, that's it. All right. So this is the last part. Oh, and put a space. Little things like this bug me. I don't know why. I probably have OCD tendencies. I don't think I would be diagnosed with it, but not having a space in between there, that would bug me the rest of the day. So I gotta change it. So maybe I do. Who knows? All right. So what are the two things we've talked about on this lesson so far? What did we do first? We did distance, didn't we? So we did the distance formula. Do you remember that? Do you have these memorized yet? Tell you what, just as a review, without looking in your notes, let's write them down. So let's do the distance formula. All right, so D equals. How does it start off? What's the first thing we put? X? Just put X? Put a big old square root. Yeah, whoops. Big old square root. I call it the shell of the formula. All right, so I like to put this stuff in here. Okay, and then I can put in the letters and all that kind of thing. Everybody with me on that? So that's what I do first thing. I put a big old square root, a couple parentheses, a plus, squareds, and then I can put stuff in. So what do I do with the stuff in here? First of all, it's going to be an x1, right? And an x what? 2. And what do I do with those two? Subtract them, right? To find the distance. Remember, find the distance from one point to the other. How do I find that? I subtract, right? The two numbers. It's like being on a road, on a highway, and you got these mile markers, right? If I'm at mile marker 10 and I started at 2, how far is that? How far is it from mile marker 2 to 10? I subtracted, right? 10 minus 2. So that's how we know to do that. So I take the x's and I subtract them from each other, and then I take, the y's and I subtract them from each other. Now, it doesn't matter if you go x1 minus x2 or x2 minus x1. It doesn't make any difference at all. Okay, the only difference that it would happen is that one would be negative and one would be positive. And you'd think, well, that would be a problem, wouldn't it? If one was negative and one was positive, it would change your answer. But it really doesn't, because what are you doing right here? So if I go 10 minus 2, that's 8, right? Or I go 2 minus 10, that's what? Negative 8. Well, they're two different numbers, right? So that should affect my distance, but it doesn't. Why not? Because you're squaring it. That's right. Because if you square a negative, you always get a positive, right? If I square a positive, you always get a positive, all right? So it doesn't matter what order you subtract them in, because I think when I first wrote it down, I probably put x2 minus x1, all right? So don't let that confuse you, though. It doesn't matter what order you subtract them in, because you're going to square it anyway, right? And so it's just going to make them all positive anyway. We good? All right, so that was the distance formula. What was the second thing we did? Midpoint. Okay, I'll just shorten it, midpoint. And so the midpoint is, now remember, it's a mid what? Point, midpoint. So this is a point. How do we always write a point? As an ordered pair, okay? As an ordered pair. So there's my shell right there, okay? And to find the midpoint, we always divide by 2, don't we? Because we find half. So that's how I can remember that. Now, what do we do with the x's up here? We add them. That's right. So we add the x's. And again, it doesn't matter what order you add them in, because when you add two numbers together, it doesn't make any difference, right? What order you do them, right? 2 plus 5, 5 plus 2, right? Even negatives, right? Negative 2 plus 5 is the same as 5 plus negative 2. It's the exact same thing. And then you do the y's right here. So y1 plus y2. All right. So that's review. All right, we got one more thing. So this lesson is kind of like 3 lessons in one, right? The reason they do that is they kind of expect you to know this already, right, before you even come into this class. You're supposed to know distance, and you're supposed to know midpoint and all that good stuff from Algebra 1. But not everybody does, so that's why they stick it in here, just to review a little bit. And that's why they stick it all in one section, all right? It's all 3, 4, because if it was algebra, they would have one complete lesson just on the distance formula. Then they have a completely different lesson on the midpoint, completely different lesson on what we're going to do today, all right? And obviously, what are we going to do today? We're going to do slopes. And you guys kind of talked about this the other day when we were mentioning this. But we are not... forget that. Let's do this. let's just put a little X and Y axis right here. Put it about right there, okay? And what we're going to do is we're going to put, let's change colors to this. We're going to put a line in here. I didn't put arrows, but pretend there's arrows on all these things, okay? Just too lazy to do that, all right? So let's put a point right here. We'll call it point A. And we're going to put a point up here, and we're going to put it a B. So what we're going to do is we're going to find the slope of the line. So the slope, that's supposed to be an O. It's weird looking. Slope, all right? The slope basically means how steep it is, all right? So look at this pen right in front of you, all right? So let's say it was slanted like this. Is that slope different than that? Yeah, this one's a lot, what would you say? This is a lot steeper. Yep, that's a good way to say it. That's a lot steeper than what that would be. Agreed? All right? And this one, what about this slope and this slope? They go in different directions now, don't they? All right? So we got to take in consideration the direction the slopes go and how steep it is. All right? And we're going to talk about both of those. So if you want to go from point A to point B. So you know, I was a hiker. I figured that I would still be a hiker, but my knee is killing me and I haven't hiked in a long time. Now, when you hike, to get the good view, you got to go up a mountain. Would you agree? Or if there was a road up there, you could drive up there and you could just see the good view. All right, so that would be kind of nice. But when you're hiking and you're backpacking for several days, you're going to have to walk up the hill. So, I mean, this is a relatively steep hill. So again, the slope is the steepness of the line, how steep it is, okay? And another thing is what direction it goes. Like from left to right, what are we doing? Like from left to right, we're going what? Up the hill or down the hill? From left to right, from point A to point B. If you started at A, you go to B. You're going up the hill or down the hill? Going down the hill. Okay. Or I'm sorry, you're going up the hill. I was thinking of something I was going to say later. All right, so you're going up the hill. So when you go up the hill from left to right, what do you think that is? Do you think that's a positive slope or a negative slope? It'd be a positive slope, okay? When you're going up the hill, so from left to right, as that thing climbs up, that would be a positive slope, all right? What if you had, I mean, I don't even have to ask the question. What am I going to ask? What if you're going what? Down the hill, right? If you're going down the hill from left to right, okay, everything's always from left to right. So if you go from left to right, this yellow one would be what kind of a slope? It'd be negative, right? The red one would be a positive slope and the yellow one would be a negative slope. So that's one thing that we need to understand, all right? So now we got to figure out, like, how steep is it, all right? So if I had, let's do this. If I had a line like this one, now is the first red line that I drew, is that steeper? Or is the second line that I drew steeper? The second line is definitely steeper, okay? And why is that? Because you go up a lot higher for just a little bit of distance across. Everybody see that? Okay, so right here, you go up a certain distance and then you go across a certain distance, okay? Right here, you got to go up a lot steeper, a lot higher, and then you just go over just a little tiny bit. Whereas this one, you go up a little bit and then you go over quite a bit. All right, so there's definitely a difference in the steepness of these lines. And we call that, and you probably heard this already, the steepness of the line we call the rise, okay, over the run. And that's what slope is. All right, let me scooch that over a little bit. Did everybody hear that in Algebra 1? Yeah. All right, so the slope, oops. Put an E right there. Let's try this again. Slope is the rise over the run, which means what? How high you go up vertically, okay, straight up. Okay, that's vertical. How high you go up compared to how far you go across. Make sense? All right, that's the rise over run. We have a letter that describes the slope. You'd think it'd be S, wouldn't you? For slope, since slope starts with an S, but it's not. Anybody remember what the letter is? It's M. Did anybody tell you why? Okay. There's really, I looked it up one time because somebody asked me that, and I'd never even thought about why they call it M, why they use M for slope. Never even occurred to me. Some years ago, some kid asked me, and I looked it up, and really there's no definitive answer. There's no, like, everybody agrees exactly on where the M comes from. But here's how I like, and this is one description. One person said it's like Latin for mountain or something like that, and it still starts with an M even though it's Latin. So the way I like to think of it, I don't know if this is actually true or anything, but I like to think of it as M stands for a mountain, right? You go up a mountain, you go down a mountain. Some mountains are steeper, some are not so steep. Is that right? Okay, good. Now, I don't know if it's exactly true, but that's how I like to think of it, all right, is M for mountain. Everybody good with that? All right, so the rise over the run. So what we're going to do, if I ask you to find the slope of this point right here, you would start here, or you could start here. It doesn't matter, but I'm going to start to the left. And I want to rise and I want to run to get from A to B. All right, and let's do this in a different color. Let's go yellow, kind of like that yellow. All right, so I'm going to start here, and I can only go up and I can only go over, up or down. Okay, I can go up or down, or I can go over. Remember those grid marks I had before? Probably should have put one of the grid mark things here. But you can only go up and you can only go over. So let's start here. I'm going to go up. Where do you think? Is that about as high as the B is? Is that close? Oops, daggone it. There we go. And then, so that's my rise. Yep, I was pretty close. Why does it keep doing that? I know why it does that. Let's try this again. Boom, boom. All right, let's scooch it down just a tad. Close enough. There we go. So this one, this yellow one right here would be the rise. And this, I'll tell you what, let's change colors just so I can say yellow and blue. All right, so the yellow one would be the rise and the blue one would be the run. Everybody see that? So what we're going to do is something like we did on that midpoint in the distance formula. We're going to put some x1, y1s in there, x2, y2s, and all that kind of thing. All right, so this is point A. So let's call this just x1, y1, that point right there. And what do we think? What do you think we're going to call point B? Good, x2, y2. All right. Now here's the tricky part. What's this point right here going to be? Well, how far over did we go to get to A? We went over what? Don't remember this from the other day? You were stumped the other day. You went over x1. That's right. In order to get to A, how far? You started at the origin, right? How far over did you get before you went down? You went over x1 because we called that x1. You with me on that? So what's the x coordinate of this point up here? That's x1, correct. All right, now, yeah, how high did you go up? See, you went over and up, and that's the same distance as this one right here. Do you see that? So this vertical distance, this y distance right here, is the same exact y distance as this one. What's the y distance of this one? It's y2. So that would be, oops, there we go again. Let's try this again, y2. Does that make sense on where we got that point? I mean, these make sense, right? Because I just called it. I mean, I could have called this one x1, y1 if I wanted to. It doesn't make any difference. But I just decided to call this one x1, y1 and call this one x2, y2. But this, if I call those two by their specific names, this has to be x1, y2. We good? So what we're going to do is we are going to find what the rise is. Well, the rise is how far, all right? It's distance. And it's just vertical, so we don't have to use that whole square root thingy, all right? It's just this yellow distance. How far is this? I'll tell you what, slope equals, it's rise over run. So what is this distance from here to here? We're just going along the y direction, right? So this point right here is y2. Pretend, because sometimes those x1, y1 things get you confused. Okay, let's pretend it's a regular number. Let's say it's like -2 right here. And let's say that's 5 right here. Okay? So what would you do to find the distance, to the rise? If you went from -2 up to 5, how far is that? If I started at -2 and I went up to 5, it's 7, right? Right, you go -2 to 0, right? So that's 2 places. Then you jump up to 5, that's 7 places. Or you can subtract, right? 5 minus what? -2. What's 5 minus -2? It's 7. You with me on that? So we just subtracted, right? I went 5 minus negative 2. So what are we going to do here? We're going to go y, what? 2 minus what? y1. You with me? Now, you're not going to have to figure all this stuff out. Remember we talked about the distance formula and the slope. This is just so that you know where we came up with these little formulas and these little equations, okay? It's not something you're going to have to do on a quiz or a test. You're just going to have to memorize what the slope is. But I think it's important. Now, when I teach this to my CP class, I probably will not go through all this x1, y1 stuff, okay? I'll just show them what the points are. I might not even show them all the points. I might just tell them what the formula is and show them how to use it. You're probably thinking, why don't you just do that with us? It'd be a lot nicer, wouldn't it? But I think you're smart enough. I think you're intuitive. I think you're interested in it enough to appreciate what we're doing here. All right. What about from here to here? What is the distance from this point to this point? Because again, this is our rise. So what's our rise? y2 minus y1. That's our rise. Okay. What's our run? From here to here. Yeah. Well, let's go in the same order. So if I went y2 minus y1, what do you think I'm going to do over here? I'm going to go x2 minus x1. So let's do that. x2 minus x1. And that right there is your little, I guess we'd call it a formula for the slope. Now, it doesn't matter what order you subtract them in, as long as, listen to what I'm saying, it doesn't matter what, you could go y2 minus y1, or you could go y1 minus y2, as long as you go in the same order with the x. All right, so I put an or right here, so I could write it what? y1 minus y2, but what's the bottom going to have to be? x1 minus x2, okay? So either one of those, all right, is going to give you the same exact answer. Why is that? Because if I go y2 minus y1 and y1 minus y2, what's the only thing that's going to be different between subtracting them in that order? What do you think? Watch. If I go 3 minus 5 and I go 5 minus 3, what's going to be different with the answers to these? The sign. Exactly right. The sign. So that's going to be a negative 2. This is going to be a positive 2. Agreed? But the thing is, depending on what order you subtract them, this is going to be one sign, this is going to be the opposite sign. So if you flip, or if you change the order that you're subtracting here, it's not going to make any difference because you're changing the sign of the top and you're changing the sign of the bottom. What's that going to be? It's going to just be a positive, right? A negative over a negative is a positive. Doesn't matter what you change the sign to, as long as you do it to the bottom. So anyway, I didn't explain that very well, but just know that as long as you subtract the top in a certain order, you got to subtract the bottom in a certain order. So, with all that said, let's do an example. And sometimes they're going to give you a graph, and sometimes they're just going to tell you what the ordered pairs actually are. Okay, so let's do the one. So this is example 4. It's in the book if you want to look at it. Example 4. So the part A, they give you a graph, and you got to be able to tell the slope of it. All right, so I'll tell you what I'm going to do. Let's grab that. Let's grab this. There we go. Copy. And then let's put it down here. Just so that we can be pretty specific. Okay. All right. All right, so let's say they put a point. Let's do this in a different color. Let's go this pink color. I think it shows up a little bit better than red. So let's say they put a point right here, and then they put a point right here. All right, and they connect them to make a line out of it. So from there to there. Oopsie daisy, what's going on? Try it later. Okay. And let's just extend that line like this. There we go. That's good enough. All right, so they could do this on a quiz, on a test, on a homework problem. They're going to give you a line, and they'll probably put it so that you know exactly where it crosses. They might probably put it on like a grid like this so you can tell exactly where it is. All right, so what we have to do is find the slope. this in white. So it says find the slope of that line. Okay, of that particular line. Well, what are we going to do? Yeah, let's do rise over run. Okay, so we could, here's one thing I failed to mention earlier, and I probably should have. You could also rise this direction and run in this direction. Everybody see that? You don't have to start with that left point and go to the right point. You don't have to. So I could have gone rise this way and run this way. But this rise would have been negative, correct? And this run would be negative. What's negative over negative? It's positive. So it still gives you a positive slope. Agreed? All right, so with that said, I should have said that earlier. That said, let's go to this. So what you're going to do, sometimes they don't actually put the dots right there. They just put the line with a grid mark. What you have to do is you got to see where it hits the intersection of those little grid marks. Does that make sense to you? All right, because like this point right here, do you know, like this point right here, do you know exactly where that point is? No, you don't. Let's do this. Let's zoom in a little bit. See that? All right, you don't know exactly where that point is because it's like somewhere in between, right? You know where it is left and right, but going up and down, you don't really know where that is. Okay, do you know where this point is right here? No. So you go until it looks like it crosses, and let's make this like that again. All right, so I actually put dots there so you know exactly where the points are. All right, so let's just let's draw this thing out. Let's go different color. So rise over run. So I rise how far? From here to here. You could just count if you wanted to. Let's do that. Let's just count. How far? 1, 2, 3. So what's my rise? But I'm going what direction though? I'm going down though, right? So it's, what's the rise? It's -3. Agreed? Now, I'm here now. Now I got to run. All right, so I'm going to start here and I'm going to go to there. So how far is that? 1, 2, 3, 4. Which direction did I go? I went to the right, so I went what? Positive. So what's my slope going to be? It's going to be what? -3 over +4. You with me on that? So if they give you a graph, a lot of times you can just count. You don't have to do any real math. You just count, you know, down and over. I could have gone the other way too, couldn't I? Let's do this. Let's change. There we go. Let's make this a little thicker. So watch. I could rise. Oh, that's a little too thick. I'll stick with the pen. All right. I could do this. I could have gone to there. Okay. How far is that? 1, 2, 3. It's +3 though, isn't it? Okay. If I go up and then I'm going to go to the left, how far is that? It's -4. So what is the slope going this direction? It's 3 over -4. Is there any difference between -3/4 and 3 over -4? It's the same exact thing. It's the same exact number, okay? Or I could just put a negative out in front and put a 3 over 4, okay? Either one. They mean exactly the same thing, all right? It's just a lot of times it looks a little nicer to put that negative out right in the middle like this. This would probably be my least preferred way of writing a negative fraction, okay? But it would still be fine. It's still perfectly fine, all right? I would usually write my fraction either like this or like this if it was a negative fraction. But do you understand? It doesn't matter where you start. Everybody see that? Because it's going to come out to the same thing anyway. All right, let's do another one. This one, they're not going to give you a graph. I'll tell you what, let's just copy that. Actually, I don't need to copy that because I just said they're not going to give us a graph. What they're going to do, this is part B. Oh, part B. They're going to say find the slope. I'll just write that down. Find the slope. And then they give you 2 points, okay? And they give you 1, -4, and they give you 3, 2. All right? If you wanted, I guess you could graph it and then count right on the graph if you wanted to do that. That would be okay. But it's not really the best way to do this. All right? What do we need? We need a little formula, don't we? Well, let's write down the formula. We've only written it down once, so let's write it down one more time just so we remember it. It's rise over run. Or here's another way we say it. I forgot to mention this. It's not that big of a deal, but this right here, when I rise and I run, this is the change in y, and this is the change in x, all right? So it's the change, right, in y, because sometimes you'll hear that from me. If you take another math class, you might hear it from them. It's the change in x and y over the change in x. The change in something, how far did you go from 2 to 10? Remember that number before? What is the change in your distance, right, from 2 to 10? It's 8, right? You changed 8 places. Would you agree? All right, so that's the change. Here's another thing. This is kind of crazy. Everybody watching? All right, you've probably never seen this before. But in math, there's a little symbol that represents the word, the change in something, all right? And it's a Greek letter of the alphabet. And it kind of looks like a triangle. But I think when they draw it, usually like one of those sides of the triangle is a little bit thicker than the rest. I don't know. I don't make it thicker. I just make a little triangle. It's a Greek letter. It's delta. Okay, I'm trying to remember my Greek letters. I think it's delta. Okay, it's the change in. So a lot of times you'll see it like this: the change in y over the change in x. This means the slope. All right. That means y2 minus y1 over x2 minus x1. That's what it means. All right. Just thought I'd throw that in there because you'll probably see that at some point later on. Maybe not in this class. I mean, we will talk about it in this class, but like in your Algebra 2 class, your pre-calc class, your calculus class, you'll see that. I don't teach Algebra 2. I wish I did, but I don't. Yeah, he's been teaching the honors Algebra 2, so I wish I could teach it. This is Halliday. All right, here we go. The reason I went through that and I remembered it because I was about to say, what is the slope? The slope is the change in y over the change in x. All right, and I say that a lot. So I want you to understand what I'm saying when I say that. All right, how do I find the change in something? Well, I subtract them. Right, so subtract the y's. And again, it doesn't matter what order you subtract them. I'm going to go like this: y1 minus 2, and then I do the x's on the bottom, x1 minus x2. How do I remember which one's on top, which one's on the bottom? Because the slope is the what? The what over the what? It's the rise over the run. So which direction is the rise? That's the y direction. Which direction is the run? That's the x direction. Okay? A lot of people get this mixed up. A lot of people put x on top because, x comes before y in the alphabet. They just figure it goes on top. But remember what it is. It's rise over run. So it's the rise, which is the y direction, and the run is the x direction. Okay? Simone, you getting all this? Getting it through osmosis? Is it all coming through your book up into your brain? Okay, but you're not watching. I want you to watch. All right, let's take a look at this. This is what I do when I first do these things, when I first teach it. Let's call this our first point. So this would be my x1. This would be my y1. What would this be right here then? This would be my x2, and this would be my y2. Everybody see that? After a while, you don't really have to do that. But at first, you might do that just so you understand. All right. So what does this say to do? Subtract the y's from each other. And again, it doesn't matter what order you subtract them, as long as you subtract the x's in the same exact order. Okay? That's important. Everybody hear me on that? It doesn't matter what order you subtract them, as long as you subtract both of them in the same order. Okay? The first one minus the second one, or the second one minus the first one. Do that for the y's, do it for the x's. Okay. So we'll just go the first one minus the second one. So what would that be? Negative 4, what? Minus 2. Okay, everybody see that? I took the first y, the second y, and I subtracted them in that order. I went the first one minus the second one. What about the x's? How am I going to subtract those? 1 minus what? 3. And now I just work it out. What's that? Negative 6. What's that? Negative 2. Do I leave it like this, though? No, you never leave your fractions like that. What's a negative over negative? It's a positive. I can't remember what class it was. I think it was my college algebra class. I had so many people write a fraction and kept it negative over negative. I didn't mark it wrong, but Don't do that. Don't keep it negative. If it's negative over negative, what is that? That's positive, isn't it? So write it as a positive. What's 6 over 2? 3. So what's my slope? It's just 3. And that's how you do it. I mean, that's a lot of explanation, but for you to actually do it, it's super quick. Do you see that? Right? You just look at it and you say, oh, I take the y's and I subtract them. Then I take the x's and I subtract them. Just reduce my fraction. Boom, I'm done. It's that quick. I mean, literally, it would take you seconds to do problems like this. We good? Okay. We talked about this a little bit earlier, but let's just talk about it because it is in the book right now. I'm not even going to put the x and y axis on here. I'm just going to draw some lines. So if I drew a line like this, what kind of a slope is this? It's a positive slope, exactly. All right, good. What if I drew a slope like this? What would that be? Be negative. Again, because from left to right, you're going down, right? From left to right, you're going up. Now, here's something that's a little bit different that we haven't talked about. What if you had a slope that was like this? It is 0. It's a 0 slope. So I'm going to put the slope equals 0. And I'll give you a little story in a second that I always tell when I teach this stuff. Now, what about this one? I tell you what, let's talk about this, though. From here, what is the rise and run from, let's say, point A to point B? Let's go from A to B. How far do I rise? I rise 0, don't I? So it's rise over run. How far do I run? Whatever the distance is, right? Okay, let's say it's 5. Okay, so it's 0 over 5. What's 0 over 5? It's 0, so the slope is 0. Okay, anybody ever go skiing, like snow skiing? When you first get out there, it's all flat before you actually go to a lift or something, right? So it's just flat. If I just stood there, right, and didn't go anywhere, what is the slope? And it's completely flat. The slope is what? 0, right? It doesn't go up, doesn't go down. It's just a 0 slope, all right? So how fast am I going to go? I'm going to go 0, right? I'm not going to go anywhere unless I push. If I just stand there, there's no gust of wind, okay? I don't have a sail or anything like that. I'm not going to go anywhere. So 0, you're going to go 0. That's 0 slope, okay? So flat is 0. What about this? Let's push this up a little bit. What about this? So what if you had a point right here and a point right here? Again, we'll call it A and B again. So again, it's rise over run. That's a slope, isn't it? What's the rise? Well, it's whatever the distance is. Let's just call it 7. All right, we'll just throw a number in there, 7. All right, so from here to here, actually you went down from A to B, so it'd be negative 7. All right, now you got to here. How far do you run? You run 0, right? You don't go anywhere. You're already there. So somebody put that in a calculator. What do you get when you put any number? Who's got a calculator? Anybody got a calculator on them? All right. You put it in there, you're going to get an error. I'll tell you right now. Okay, you're going to get an error. And what we say in math is just what Simone said. We say that it's undefined. Okay? Or a lot of times they say there is no slope. Now, there's a difference between no slope and what was the last one we did? 0 slope. 0 is a number, okay? You can use 0. You can multiply by 0. You can add 0. You can subtract 0. You can't divide by 0, like right here. But you can do stuff with 0. 0 is something. It sounds weird, but it is. It's a number, all right? But this right here doesn't exist. If you ever go snow skiing and you go to the very, very top, what diamonds do they usually call it? It's a black diamond, right? You go to the black diamond, the blackest diamond they ever have, okay? There is no way that they're going to have a slope that goes completely vertical, completely straight down, right? You're always going to have some kind of a slant to it, agreed? It's never going to exist. So that does not exist. You will never, right? So here's the ground, and here you are. There you are, and here's your skis, right? There's the little tip of the ski, and there's your arms. So there you go. So you're going like this, and you're like, okay, I think I'll do that quadruple black diamond. No, it wouldn't exist. There's no ski resort in the world that would exist, right? Because if you hit the bottom, then guess what? Then you wouldn't exist, would you? You would be what? You would be undefined, right? They wouldn't be able to define you. They wouldn't be able to tell who you are if you went down a big old mountain straight down like this, okay? Nope. There's no slopes. It does not exist, all right? So there is no slope that exists that looks like this, okay? Quick story. Let me tell you a quick story. I'll tell you what. Let me put the homework on here. I'll tell you a quick story. So the homework is what? Did I give you... Why did I put down 13 to 22 on here? I wrote that on my paper. You've already been assigned that one, right? So what was this one again? I don't have the paper in front of me. I'm sorry, I wasn't listening. What'd you say? 23 to 36. Okay. Yeah, for some reason I wrote down 13 to 22. Did I already assign 13 to 22? Okay. All right. So that's your homework. Page 133. Okay. All right, let me tell you my story. Everybody listening? I tell a story every year. I don't know if anybody's interested, but you're going to hear it anyway. All right, so when I was in college, I was in a thing called ROTC. Do you know what ROTC is? It's Reserved Officer Training Corps or something. I forget exactly what it stands for, something like that. Well, they can. So I joined for a semester, all right? And we went out, and they gave us like M16s, but they were blanks. They didn't have real bullets in them and stuff. I remember we had to clean them, take them apart. We cleaned them. We went out one time, and listen to me. So we went out one time. We did an overnighter. Shh. Listen to me. Listen to my story. Don't pack up. Listen to my story. Okay. So we would go out and do some stuff like that. Sometimes we drill, and they teach you how to march and how to salute and just all that kind of military stuff. And it was kind of fun. Well, we went one time. We went to VMI, which is Virginia Military Institute, and that's close to where our school was in Virginia. I went to Liberty University. So we went out there on a Saturday, and we were going to do rappelling. You know what rappelling is? Where you hook up to ropes and stuff, and then you jump off mountains and all that stuff. And everything was going pretty good. And let's pretend this is me at the top of this right there. I had a rope and everything. I was actually I was this way because you actually go backwards, all right? So I'm stepping off right here, and you're hooked up, right? You got this rope, and, you know, you're not going to, I mean, if you let go, you're not going to die. You're just going to hang there, okay? So I was all right. I've seen a bunch of people go down. And then, so I went to the edge, and they said, okay, boom, boom. Oh, it was pretty high. It had to be, I don't know exactly. It had to be 80 to 100 feet high. I mean, it was up there. And there were big old boulders down the bottom of it, right? There's all these boulders, and nothing but just hard rocks, right? So if you would have fallen, you absolutely would have died. There's no question. Nobody would have been able to survive, right? But here I am, that's my legs, and I'm holding on to the rope, right, which is hooked onto there. And the guy's like, okay, get perpendicular to the mountain. And this is just a sheer cliff, just completely straight down. He says, get perpendicular, right? And I thought I was perpendicular. I thought I was like this. He's like, no, lower. So I'm letting up the rope because I'm holding on to the rope, right? And so if you let up on it, you can scooch down. So I'm letting up on the rope, and I swear I was perpendicular. But all of a sudden, my feet just came off the mountain. And so now, here I was here. There's my feet, and I'm holding on to the rope. I'm completely straight up and down. My head was pointing to all these rocks down here. And then all these people came running over to the edge, looking over the edge at me as I'm hanging down, right? And these guys from VMI, they're like incredible Army guys, right? They're like, not Green Berets, I don't know what they are. They're Army Rangers is what they were. And the guy's yelling at me, don't move, we're coming down. Don't move. And I wasn't that far. I was just a little bit, above here. And I was like so embarrassed. And I saw all these people coming over to the cliff, and I saw their eyeballs, looking at me. And here I was completely straight up and down. I'm like, there is no way I'm letting these guys rescue me and be embarrassed and getting pulled off this mountain. So I kind of bounced. I bounced back and forth until finally I got where I was supposed to, like this. And then I went boing, boing, like 2 bounces down, and I got down faster than anybody else. And the dude that was down here at the bottom, he was waiting for the people to come down. He's like, well, you had a rough start, but you got down faster than anybody else did, that's for sure. And I was like, there's no way I was going to let anybody. So that was my no slope story. I always like to tell that.
I'm telling you, I'm not being scared. I'm not being embarrassed. I'm scared I'm going to fall down.
Yeah. I was more embarrassed than I was scared. I tell you, I really wasn't scared. I mean, I felt secure. I was hooked up to the rope and all that stuff, and but I survived, as you see. I was just embarrassed. But some of these guys, these Army Rangers, right? These Army Ranger dudes, they would just run. I mean, they'd be hooked up to the rope, right? But they'd run like forward, and they would just leap, woo, like this. And then they would bounce once, and then they would bounce again. It was absolutely incredible. I would have never done that. I mean, they ran full speed, right off this cliff, and they're just hooked up to a rope. That's why they're Rangers, that's why they're the top, the top Army guys that we have. It was pretty incredible. It was really kind of fun to see. But that was my no slope story. And so hopefully you remember no slope and me almost dying. So, alrighty.